So, hello, I am the guy from a Voxer company, and I'm currently in charge of TLS and crypto modules in Node.js core. So, the people often think that the TLS and the crypto is kind of magic thing and sort of complex, and this is mostly due to the fact that the TLS and SSL and crypto is all written in C and the C++ bindings in the Node.js itself. So it's really hard to understand and sometimes a bit painful to read. But what if the TLS protocol, for example, would be written in a forced scripting language like JavaScript, and it will be just a bare protocol implementation, so it won't have cryptography inside it, like hashes and encrypting the stuff, and it will just only call out the simple OpenSSL bindings for this stuff. So this is what I'm going to mostly talk about today. This is a TLS.js module, which does this stuff. It's a JavaScript implementation of TLS protocol. And yeah, you could install it from npm right now if you want to, and just go ahead and hack with it. So yeah, I was going to show you some really awesome demo about the Wi-Fi capturing device isn't really working well because there are a lot of people. So I'll probably just do you see anything here? Oh, okay. Okay, so I'm just going to start a capture locally. And using a TLS.js module, I should be able to perform a man-in-the-middle attack on this website. And for example, I hope things go well. Oh, okay, yeah, it works. So this is completely running with the TLS.js module, and basically what it did here, it has captured all local traffic, local TCP traffic, and using the private keys that was, let's say, leaked via Heartbleed or something like this, it was able to decrypt it. Yeah. So this is why TLS.js is awesome, and you should use it. Well, this is outdated stuff. Okay, so this is a link to an implementation of this demo, and so yeah, it should be a nice reading for a weekend if you don't have any plans. So how does the TLS protocol work anyway? It is really fully described in this specification, but if you will open it and start reading, you will soon find out that it is scary and has lots of pages, and well, it's just impossible to follow. But after some time, if you will drop out the minor needs and version compatibility and version difference and the compatibility stuff from it, you will see that in its core, the protocol is actually pretty simple, which was surprising to me because I saw this complicated. So before we'll dive into the depths of the protocol and get totally bored and tired and our eyes will start bleeding, let me show you some useful information that you will probably be able to use in your everyday lives. I'm going to have a short note about cipher suites. Cipher suite is one configuration options for a TLS server. So this is probably the most important thing that you should consider when deploying a TLS server in Node.js or Nginx or any other web server. So the cipher suite itself is a collection of algorithms. So this protocol, the TLS, is performing encryption, and this encryption is performed by some different algorithms, and some hashing could be used. So the cipher suite is a collection of these ciphers from different categories like key exchange, authentication, and encryption, and some hashing. And if you will just take one cipher from each of these categories and put them in an array and join them with a dash symbol, you'll get string like this, or probably even this, but don't use this one because it's totally unencrypted, and yeah, it's just the best way to get your website hacked. And yeah, so this is what you normally do pass to a TLS server when configuring it. And this is a way to tell the OpenSSL what algorithms, what security measures you would like to use on your web server. So if you want to see what other algorithms are supported by OpenSSL, there is a command that could be run on almost any laptop or server and this OpenSSL ciphers -v if you don't see it. And it will print out all the ciphers, all the algorithms that are supported by the OpenSSL. You could also pass a string to OpenSSL ciphers to verify that it indeed matches the proper cipher suite. Well, so you know what the cipher suite is. The main thing about it next is order of preference. So you usually use multiple cipher suites in a web server, and it does matter in which order they are placed, because some cipher suites offer stronger encryption, some cipher suites are more often implemented and supported by old browsers like Internet Explorer 6 or something like this. And when ordering them, I have a small recommendation for you to order them. This is a preference criteria. So you should respect the ciphers with the EC, DHE, and DHE prefixes, which are perfect for secret ciphers. This technically means that for every connection, every time the browser or the terminal client or something like this will connect to a browser, it will use and generate a different key pair, so it won't just blindly rely on a RSA key, and if the RSA key will be leaked, the conversation still won't be able to be decrypted. So this is the first thing, and the second thing is cipher strengths. So use AES 256 and use GCM mode. I'm not going to really cover what it means, but just if you see this label, it means a good thing and probably should be included in your configuration. And the last thing, but it is still important too, so you should be using stronger hashes. So don't use MD5 ever, and probably avoid SHA-1 because Google considers it insecure right now. Well, yeah. So don't forget to support all the clients. And here is a cipher suite list that I'm using on most of my web servers and recommending to people if they ask me. And you should probably consider using it. And yeah, here is an example how it could be used with Node.js. So there is a ciphers object option for a TLS server. And yeah. Okay, so after you will configure this, you could always check your website on a SSL Labs website, and if everything is good, you will get something like this. If things are much worse, you even get an A rate. Okay, so now moving back to TLS.js, and the TLS.js is a protocol implementation, as I already said. So the protocol consists of three parts. It's a framer. This framer is a thing that is capable of generating some binary data out of the JavaScript objects. So here I pass some JavaScript object, and the framer, it is a readable stream. It outputs the buffer, or it could be just piped into the socket, which TLS.js does. The parser does the reverse process of this, so it's just parsing the binary data, piped from socket or maybe from framer, and emits things like this. So it emits JavaScript objects. And the last thing in TLS.js is a state machine, which is actually implementing the protocol itself. So it receives the frames from parser and decides what to do next with them depending on the current state, and sends all the frames and setups on the encryption. So let me show you some examples of TLS.js and how it is actually used and how the TLS protocol is actually working. So everything starts with a handshake. So the client establishes a TCP connection with server and sends a client hello record, which contains the cipher suites that it does support. And this list could contain one or more records, and technically it means how good the client is, because if it doesn't support strong ciphers, it's probably outdated. Then server receives this and replies with a server hello. And the server hello basically contains one cipher suite. So it takes the cipher suites sent by the client, intersects them with the server cipher suites, and replies the most perfect cipher. So at this point, right after this, it sends a certificate and indicates that hello sequence has finished with a hello done. And now, at this point, both sides, the server and client, know the algorithms that they are going to use because they know the ciphertext, which consists only of algorithms. But the algorithms by itself, they just don't work. So you need to have some sort of encryption, decryption key to be able to securely communicate. And such data should be negotiated in the next stage. Here comes key exchange messages. So in case of my demonstrations that I was showing to you recently, the server was not really greatly configured, and it didn't have a perfect forward secrecy suite, so it was just using RSA key for everything. And in such case, the shared secret that both sides are going to use, it will be just a random data, and the client generates it, encrypts it with a server's public key, so no one else except the server will be able to decrypt it, and sends it in a client key exchange message. So server is receiving it, decrypting it as a private key, and yeah, at this point they know some sequence of bytes, and this sequence is a shared secret that they're going to use for all future stuff. But this shared sequence length actually do depend on the key exchange algorithms that was used for it. So its length is usually much shorter than it is actually required to be able to generate the keys and encrypt the stuff. So the TLS protocol expands this data with a PRF function, which stands for a pseudo-random function. And in a pseudocode, it looks like something like this. So it just sets in some seed of the random number generator and sets it to a pre-master secret that they have just negotiated, and then just takes the random bytes from the generator and uses them as the keys. So at this point, both sides know algorithms and data, and they're ready to encrypt the data. And they are telling each other that they're going to send only encrypted packets at this point, and this is done using a change cipher spec message. And they send a finished message, which technically used to verify that both sides are on the same encryption and the handshake was modified. So this finished message is actually encrypted with this new cipher and data. And yeah, this is the point where the client and server in Node.js emit secure event, and Node.js could actually write some stuff in and out. So again, clone the TLS.js repo and try reading it. It actually isn't really hard. And then once you get used to it, you should probably try to fork OpenSSL. And after reading TLS.js, it should be much more familiar to you. But since TLS.js is in JavaScript, and you will be able to project your knowledge to a C and probably prevent next hard bleed sync or something like this. This is really possible, yeah. So, well, I don't know if I have more time. Do I have? No?
Well, you have like 2 minutes.
2 minutes. Okay, side notes. I have also recently worked on a tool called BUT. BUT is a TLS babel-fish. So if you read the Hitchhiker Guide to the Galaxy, you probably know what this is. So BUT is a server that runs in front of your, let's say, HTTP server. So your HTTP server doesn't need to care about encryption and TLS and the rest stuff. So it just takes encrypted data, proxies, clear text, decrypted data to your server, and performs this action in reverse. So to the clients, the external clients, it appears like a HTTPS conversation, but in fact, your backend just doesn't care about it at all. So what features does it have? First of all, it runs on libuv, which is kind of cool, and we all use it and run software on it in some way or another. And it has really nice JSON config. So that's probably the main pros of using it. Yep. And yeah, it has lots of features like async, sync, SNI routing. It's really useful for platforms as service when you have one big balancer that is balancing HTTPS traffic to different actual servers. So like this balancer is running on one IP address, but serves multiple domain names. So each domain name has its own certificate, and SNI could be used to select the certificate dynamically. So without needing to put in all these private keys on the single place. Also, it does support the sync of CSP stapling. It's a really good thing, and it appears to be much better since the Heartbleed, because lots of certificates are being revoked right now, and the only way for browsers to check it is to actually request the certificate authority and ask it, is a certificate still valid? But with the CSP stapling, the server could automatically provide this response from a CA, and thus it will be much faster and simpler for clients. It also does support backend balancing, and you could just put hundreds of backends in your configuration and configure the bot to balance to different backends depending on the, let's say, server name or IP address of the clients or something like this. And yeah, it has dtrace hooks, which I'm not going to cover. Also, it does support DSO loggers, so you could write an external logger in a C or some language and just include it in the configuration and run it. And yeah, well, it's pretty much all, yeah. So yeah, thank you.